Okay. Hi, I'm Nate, and this is I don't even need this. Here we go. I thought this was running. Oh, there we go. Oh, sorry. No, that's not right. Hang on. There we go. So this is going to be a little talk about what not to do or how not to code when you're using MongoDB. This is based on my experience developing this thing right here. It's a product called RevJam. It's a social commerce app. I know what you're thinking. It is not Groupon. It is also not a clone of Groupon. So don't ask. Basically, the gist is you input some information about yourself, what your interests are, and the system finds really good deals for you in your area. And I won't get too much into that. If you want, you can come to our party, which I probably should have announced is happening on the 26th. And I think you can go to revjam.com to get an invite to that. I'm not positive. Anyway, so this talk is going to be about my experience and what I've learned about MongoDB from building this thing. It's been about a year and a half in development. And over the course of that period of time, we ended up pivoting, as the, I think, enterprise startup speak people say it, a lot. There's supposed to be this joke that if we pivoted enough, we would have ended up back at the original idea. That didn't happen, but we probably got pretty close. So, who am I? Actually, one other person who's not here, he's here with us in spirit, he's not dead, he's just in Canada, is Joel Perra. He is my partner in crime on this project. And he went to school for theoretical physics, and he's a ridiculously smart guy. But for some reason, he does PHP. And I do too. So he knows all kinds of languages and technologies and stuff. And working with him is great because it's almost like I don't even have to be smart. Because whenever I need like a really complicated solution for something, I can just ask him. He's also a part-time internet superhero, and you can search his hashtag on Twitter. And this is me. I am the lead developer of a framework for PHP called Lithium. It's all new fanciness. Just out of curiosity, how many people do PHP? Okay, so a few. It's better than I expected. So check it out. I've been working on and with MongoDB for the past couple of years, mainly on RevJam, but on various other projects as well. And I will be your host for the evening. Along with myself, I've been involved with the guys from 3 other projects, Mapalong and GimmeBar and Totsi, and all 3 projects use PHP and Lithium as kind of the base of the stack, along with obviously MongoDB. Mapalong and GimmeBar both use Python and Erlang respectively, so there's a real diversity of technologies there, and that I've had a little bit of experience with and heard some of the stories from some of these other guys working on this stuff about some of the pain points there. So without further ado, I will get right on with it. So the first major pain point when you're dealing with MongoDB and you try to do certain things is that certain queries and certain types of queries will block, which means they prevent other queries from happening. So a group query, it's really standard kind of aggregation query when you want to group on the value of a certain field. That can potentially be really slow and lock up database resources. So for one of the original iterations of RevJam, we had this as part of a backend where advertisers would be able to log in and kind of select the group of people that they wanted to target for a particular advertisement. So what would happen is we would do a group query for to generate each one of these graphs that would basically just group all the people of a certain age, all the people of a certain income level, and graph that out over the entire user base in order to create this graph that people can use to select. And that was pretty simple. In Lithium, we have a really basic MongoDB abstraction layer So you can do a group query for example, age, just by doing that. You tell it what the key is that you want to group on, and you give it the reduce function as well as like the initial object that you want to start with. So it's really, really simple. This is for age. Grouping by income was actually a little bit trickier and involved some other JavaScript that you don't see here because we actually rolled up by 5K income increments. So it was a little bit more complicated. And that partially involved the next thing, the next step that this query required, which was where. Where, because it executes, because like group actually, it executes JavaScript on the server. It's actually a lot like calling eval. It creates the same kind of a write lock on your database, which can really, really slow things down. Now, this is all anecdotal. I'm not an expert. We have actual 10-gen proper engineers somewhere here, right? Don't we? Yeah. Hey, so I'm going to be asking you questions and stuff. So we had this this where function where, because both of those ranges, both of those graphs that you saw actually allowed people to select arbitrary ranges and multiple arbitrary ranges, we had to do this really complicated query. Well, it's not super complicated, but compared to most queries, it's complicated. And so we had to run this for each of income and age selection to figure out which users were targeted by this particular selection. So, and everything was fine, and we didn't really notice that it was going slowly because at that point we had just been working on this on our local development machines, no big deal. And we were chugging along, and then one day we decided to add sessions to do our session storage in Mongo. And once that happened, it went about to like that. Not literally, but it was really, really slow, like maybe a couple requests a minute. Because what was happening is these hugely expensive queries were locking all the server's resources up, and writes particularly were a problem. So if you had like the site open in more than 2 tabs, or you were trying to be logged in multiple browsers with more than one user, the session activity would be blocked by these really, really expensive queries. So Joel is, again, he's the really smart one who makes me sound really smart, and he has this to say. So this global locking is an issue, and the only real way to get around it for these really expensive queries is to shard. Because you can send unlimited queries to the Mongo S, which is controlling all of your shards, and that can handle unlimited operations, and the locks will still happen at your individual instances, but unless you're doing a lot of this stuff, which I don't recommend, you're not going to be locking your entire cluster. So locking is bad, and here's my really, really scientific graph about how much locking happens per operation. So it's a lot. It's kind of a lot for all of them. So all that stuff, try and avoid, right? But don't we have a really simple solution to all this? Of course, MapReduce, right? We don't need all this stuff. MapReduce will solve all of our problems. Except in this case, it was kind of difficult because for each of these graphs were being dynamically generated based on other parameters on the page. So every time somebody updated some other input in this screen, these graphs would actually have to be dynamically regenerated. So MapReduce is great, and it runs reasonably efficiently on a sharded setup and all that, but you can't. It's not fast enough to produce the real-time results that we were looking for. So what can we do about that? Well, replication. Replication is great because you can actually end up making effective use of those shards by distributing load and distributing these reads across multiple servers and multiple sets of processing power instead of just locking up your one server. Now that's great, but you're still going to get a little bit of that lag because if you have a lot of these to do, it's going to add up. So that's where read slaves come in. And by default, I think, doesn't Mongo actually send reads to slaves in replica sets as of some version?
Slave, okay.
Okay, well, fortunately, that's the next slide. So you can actually set slave OK at any level. So you can set it for your entire connection, or you can set it just for one database or collection, or even just one record set, or result set, rather. And I found this little note in the manual, which I thought was funny because it was well written. Twiddling knobs and setting slave OK. Basically, you can kind of make it arbitrarily switch to some other random slave. So if you find during the course of a request that one slave is getting slow, you can just tell it to switch to a different slave. It chooses it completely at random. You don't get to pick, but hey, it's better than nothing. So another kind of contentious issue in MongoDB is auto-incrementing. Now, a lot of people, you get that kind of a look. It's like, what are you doing auto-incrementing in MongoDB for? We use UUIDs, and that's the truth. Well, there's actually a lot of really good reasons to use auto-incrementing IDs, and they all have to do with humans and not so much technology. Like the /dot user ID system, for example, where a really low /dot user number is like a symbol of really, really geeky status, but status nonetheless. Invoice numbers, also another valid use case. And IDs get used a lot in URLs. So if you want to have like shorter or friendlier or easy to remember URLs, it's a lot easier to have just regular numeric IDs instead of these big long UUIDs. And this one actually came up in my work with my friend Mitch on Totsi. They were using obviously UUIDs for everything because it was actually the first fully MongoDB e-commerce platform. They use MongoDB for everything, including the financial transaction stuff. But anyway, they were using Mongo IDs for order numbers. So when someone would call into customer support, they would have to read off this ridiculously long UUID to a customer support representative in order for their order to be looked up. And so people were having a real problem with this. So they decided instead they're just going to use auto-incrementing IDs and hope for the best. Actually, I think they might have just been using randomly generated integers. I hope they fixed that. But anyway, yeah, so another really, really valid use case for doing that. And you know what? Sometimes, just whatever the reason, you might just want to do it. And that should be an okay thing. And generally, the Mongo community is pretty good about not giving people flack for anything, but that was one issue where it was like kind of a contentious issue, where instead of just helping someone solve the problem, it's like, why are you doing this? So there are plenty of valid reasons, and it's not a super obvious thing as far as how to approach it, but the reasons are still, the reasons for approaching it are mostly human and mostly having to do with people, whether it's just ease of memory or ease of just working with an ID in general. So won't someone please think of the children? So one approach to generating these IDs is having what Flickr calls ticket servers. This is their. Can you speak a little louder? Sorry? Can you speak up a little bit? Sure. I'll try. Yeah. So Flickr, they seem to be doing a pretty good job of scaling. So whatever they're doing must be working. But one of the things that they use is ticket servers because they have the same or similar system for generating primary keys. They have obviously very, very sharded setup, and they use these ticket servers just for generating IDs. So there's no other queries that are running on these machines. They're just for generating IDs for other stuff. So in each of them, they have a table that has the name of a table in another database and a counter. And the number one generates odds, number two generates evens. I didn't really figure out the explanation for how they add more ticket servers, but you can read about it for yourself. There's a link right there. So in Mongo, it's actually a lot simpler than having a bunch of servers. You can just have a collection that has all of your different collection sequences, and the ID can just be the name of the collection, and obviously you have your sequence. And then you can use this find and modify command to actually pull an ID at the same time as you're incrementing it. So it's completely atomic, and so there's never any locking or contention issues. Just make sure whatever happens that you don't shard that, because that kind of defeats the purpose of having one central place to have all your tickets, or your IDs rather. So another kind of weird quirk with Mongo, some of which is the result of JavaScript being weird, and some of this is the result of people not being careful. Which one of these are integers?
Either.
Anybody guess? No, you can't. So yeah, so he kind of ruined it, but the correct answer is neither of these are integers. It's a trick question. So JavaScript only has one type, and or one number type rather, and it's ECMA 262 says it's a double precision IEEE 754 format. How do I know this? Because Crockford tells me so. So now, PHP, for example, right? Like at the top, PHP doesn't really care because it's a really, really loosely typed language. If it looks like a duck and quacks like a duck and all that good stuff, then it's obviously 42. But in Python actually uses like a proper type system, whatever that means. But if you give it a double, it's going to treat it like a double, and it's not going to know that it's the same thing as an integer. Maybe Python is being too strict. Maybe this is something that could be fixed in the Python driver. I don't know. Is that no?
I don't worry about that.
Oh, okay. So whoever works on the Python driver.
What's the problem? I'm sorry.
So the Python driver from Mongo always returns doubles, like Python doubles,
Okay.
for any integers. So
Can you cast them?
what's that?
Can you cast them? I mean, the core Mongo server actually supports more than double. It's really JavaScript shell.
Right.
There's a custom long you can actually insert longs as well through the shell.
Yeah, like that.
Yeah, exactly.
Yeah, so if you want to fix this, you have to do that, which is, I don't know, I think it's kind of annoying, but it's cool. So number long, that's actually not a JavaScript thing. So if you try it in your browser, it won't work. So number long, it's like a BSON thing, right?
Yeah.
Yeah,
Well,
okay.
Extension to the language.
Right. Okay, so so it's just like a shell thing to fix something internal in the server, or?
Well, the server understands data types properly.
Okay.
And you can, through the drivers, you can actually insert data properly as double, long, int,
Oh, okay.
bit. But it's actually really the shell access when you're in the shell.
Okay.
It's limited to JavaScript because it's JavaScript from shell.
Right, obviously.
So that's really only where that's an issue.
Okay. Yeah, I don't know. I haven't tried inserting with PHP and comparing with Python. Like I said, this is all just anecdotal, just
As
stuff.
As long as it's cast properly, it'll go into the database properly.
Right.
You just need to take a lot of care,
Yeah.
especially in loosely typed languages.
Right. Yeah, and PHP, just like you don't even know. So another thing that I see occasionally is stuff like this. So this is a sort by the end date. Somebody tell me why the last document is out of order with all the rest of them.